In this video, we are going to take a look at the smooth sketch constraint, smooth or G2 continuous curvature. Notice it says it applies continuous curvature condition to a spline. We are going to dig into that a little bit, really see what that means geometrically, mathematically. And to do that, we're going to start with a line. I'm going to fix this line in place. I'm going to be sure that endpoint is fixed as well. I don't really like to use that fixed constraint a whole lot. We'll talk about that in another video. But I want to do that for right now, just to keep this line in place without having any dimensions or other constraints cluttering this up. But let's draw an arc to review what tangent does and see then an introduction to the idea of curvature and why this smooth constraint matters. There's an arc. I don't care what the radius is right now. But one thing Inventor will let you do, right-click on here and display curvature. Now see those little lines that appear? That tells me how curvy, jumped away from me there, that tells me how curvy this line really is. And those are just an arbitrary display. You can go in here and change that. You can make those lines longer or shorter just to fit your view. You can add more of them, but just know that the longer those lines are, then the more curvature we have here. I'm going to apply a tangent constraint now. And notice what we have as we go from line into arc. That tangent constraint, by our common definition maybe, did smooth out the transition from line into arc. But notice what we still have. We still have an immediate change from the line with no curvature into the arc with constant curvature. Now I'm going to delete that arc, and I'm going to draw up here now a spline. Let's start on the end of that line. I'm going to go ahead and be sure I go up off of that line. I don't want to be tangent to it right now. And I'm just going to throw a few points out here to create that spline. Look at what I can do. I can click on these control points and drag them around. And as I do, it changes the behavior of that spline, changes that curvature. But what I really want to emphasize is the behavior where we go from line into spline. Notice right here, I still have that breakpoint, and I can come in here and apply a tangent constraint to those two. And now that spline is tangent to that line. If I display curvature for the spline, see there's the indication of changing curvature. All those lines are different lengths. We have changing curvature all along that spline. Even though I have a smoothish transition here at the beginning, notice what I do have is an immediate jump from no curvature to some curvature right here at this endpoint. And that is with the tangent constraint. Now I can apply a smooth constraint right on top of that, or I could apply the smooth constraint from the beginning. But see what happens when I apply the smooth constraint. Look at the transition point from the line into the spline. Let me drag some of these points around a little bit. That things sometimes jump and get messy. But at this transition point, see these curvature lines out here? I don't have any of that right here at the beginning. If I set up my curvature display and make those lines even longer, I can exaggerate that. And now they're all over the place, but I had to give it that much curvature display to start to see right here how this begins to break at a more reasonable display. Let's take that down a bit. There, that looks a lot better. But we can see how at this transition point we go from no curvature and then just gradually begin moving into some curvature of that arc. That is what the smooth G2 constraint does for you. It really does smooth out this transition more so than just a tangent constraint. And I can display the curvature on that as well. See those lines that we have on that arc immediately jump into a significant amount of curvature, whereas for the spline with the G2 constraint, then we have minimal curvature there. I'm going to finish this sketch. Actually, I need to get back in there. Let's project geometry and get the edges on there. This sketch is not fully constrained. I can come in here and apply dimensions to all of these points along this spline. I'm not going to do that right now. What I want to do, though, is kind of illustrate what this smooth constraint gets us when I extrude this and cut across the top of that part, cut through all. I'm going to change my display, as I have these shaded edges. I'm going to go to realistic now. And even though when I put my mouse over it, I can see I have two separate faces, what it gives me is a nicer, smoother transition. This comes into play a lot in automotive exterior and interior surfaces, transitions on automobiles, that the designers, engineers there want it to be a smooth, continuous transition from one surface into another. Keep in mind on this one, we did do a line into a spline. I'm not going to go through all of it again, but I will put on here, you can have, so I could have one spline there, and then I can create another spline there, and I can apply that constraint spline to spline. If I create one and create another and want to join them, I can join them with that smooth constraint as well. We are nearing the end of this series on sketch constraints. We will cover symmetric and equal constraints and then come back around to the one we skipped over, which is the one we mentioned briefly in this video, which is the fix constraint, what uses it have and when you need to avoid it. I do appreciate you watching. If you've made it this far and found this useful, I'd love to get a thumbs up. Subscribe to the channel if you have not already. And here on the screen is the link to the next video, symmetric constraint. And if you want to get back to the playlist of all of these, here is that link as well. Thanks for watching. Have a great day.